Hey everybody, this is your homework assignment, but I'm going to do some of them for you, and that's going to be my way of, giving you some notes and some direction on how to do these. This is a sort of callback to section 5.2, I believe. Now, I don't know what that means to you, but it's basically the systems of equations. Section 5.2 was when I would give you a system of two equations, and you would use the substitution method or the elimination method to to solve for x and solve for y. And those algebraic methods were sort of shown, proven, I guess. We didn't really do much in that regard, but, as far as like those two methods being compared to the graphing method, the graphing method's great, graph the two lines and see where they might intersect. That method's great, but overall it's not as reliable as the substitution method or the elimination method. Now, this assignment is basically the same stuff, but instead of them giving you the system of equations, the two equations, they're giving you sort of like a little word problem, and you have to come up with the equations on your own. And just a little bit of, just to kind of double down on kind of like what's going on behind the scenes, I guess. In these story problems, there's going to be two unknowns. So there's two unknowns. In other words, there's going to be two variables. And when there's two variables, when there's two unknowns, you're going to usually need two equations. And that's why the word of the day here is, system. Solve the system. Because if there was only one unknown, if there was only one variable that was not known, you would only need one equation. But when there's two unknowns, you usually need a system of two equations to solve for it. So I'm going to do number 1 for you. Find the value of the two numbers if their sum is 12 and their difference is 4. Well, once again, my first unknown is going to be the first number, x. I'll call it x. And then the other number I'll call y. And now, once you've kind of identified the unknowns and you've kind of assigned them variables, now you can write your two equations. You have to milk all of these word problems for like two equations. Now, number 1 goes like this. The sum of these two mystery numbers is 12. Well, there we go. X plus y apparently equals 12. There's an equation. The sum means the answer to an addition problem. And then their difference, which means subtraction, their difference is 4, which means when you subtract them, you get 4. So x minus y should equal 4. Now, apparently x is going to be the larger number. I guess I could have said y minus x. It doesn't matter. You're just looking for the two numbers. All right, now that you have the system of equations written, now that you've come up with your two equations, now you just got to pick your method. Substitution method, elimination method. I'm going to pick elimination because not only are these equations already lined up, the x's are lined up, the y's are lined up, equal signs lined up, regular number constants lined up. Not only that, but even more perfect, the y's are already opposites. Remember, the elimination method relies on you adding the equations together, but first there's got to be opposites. Positive 1y and negative 1y, they're going to cancel out. 1x plus 1x is 2x, the equal sign. 12 plus 4 is 16, and so now you have the equation 2x equals 16, and when you divide both sides by 2, you end up with x equals 8. So apparently x, the first number, the larger number, is 8. And now you can figure out the other number, like, I mean, it's pretty obvious what it is, but usually you plug it into one of the equations now. You take this answer and you plug it in. So I'm going to plug it into the first equation, 8 plus y equals 12. And then when I subtract 8 to the other side, I get y equals 4. So there we go. There's the answer. The first number is 8. The second number is 4. I'm going to do number 3. I'm going to go a little bit in a weird order here. The next one I'm going to do for you is number 4. Okay? Let's read it together. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So there we go. There's our 2 unknowns. The price of a senior citizen ticket. I'm going to go ahead and call that S, even though S's can look like 5s. Just I'm going to write neatly, I hope. And I'm going to say the price of a child ticket is going to be C. Okay, my 2 unknowns, 2 variables. Now I got to make 2 equations. Well, my first equation is based on how 3 of the senior citizen tickets and 1 of the child tickets, whatever, equals 38. So 3 of these types of tickets times the price of each one, which we're just calling S for now. And then we have 1 child ticket, which we're going to multiply by the price of that ticket, C, we're calling it C for now. And apparently that totals 38. And then on the second day, I can use my second day information to make another equation. Once again, 3 of these types of tickets, when you multiply to the price of each one, which we don't know right now, but I hope it makes sense to you that we're going to multiply the number of senior citizen tickets and the price of each one. And 2 child tickets, so it's 2 times C. 2 of these times how many each one costs. When we add up those 2 quantities, it's supposed to equal 52. All right, there we go. Just like that, I have my system. Now I can solve by whatever method I want. Once again, I'm going to choose elimination method. But remember, you need opposites. I don't have perfect opposites right now. The S's are not opposites. The C's are not opposites. But maybe I can make the S's opposite. Like 3S and 3S, if only one of them was a negative 3S, well, I can make that happen. Let's multiply, because this is how you make adjustments when you need to, right? You multiply some number, whatever it takes, whatever number you decide will get the job done. You multiply that number to the entire equation. You're allowed to do that to kind of change up the equation. So this will make this top equation into negative 3S, but that becomes a minus 1C, and the 38 becomes a negative 38. The bottom equation I'm not changing. And now that there's opposites, bam, now I can add the equations together. Negative 1C plus 2C is 1C, which is just C. Negative 38 plus 52 is, 48, 52, 14, I do declare. So C equals 14. Now what was C again? Was C the number of, no, C was the price of each child ticket. So $14 for a child ticket. And now that you know what a child ticket costs, you can very easily figure out what a senior citizen. So let's toss it into 3s plus 1 times 14 equals 38. I'm going to use the original top equation. So this is just 14. When I subtract 14, okay, because 1 times 14 is 14. When I subtract 14 to the other side, I get 3s equals 24, I do declare. And then when you divide both sides by 3, you get s equals 8. Remember, s was the price, so $8. So apparently $8 for a senior citizen ticket and $14 for a child ticket. A few more. More good news. Number 5. If you want to do number 5 as like sort of a bonus, you know, I can't give you bonus points, but hey, feel free to try number 5. It's kind of a unique problem. Writing the equations, I'll be impressed. But you can do it. Or guessing and checking. Just remember, guessing and checking could work. But anywho, number 3. I'm going to do number 3 for you. So let's do number 3 together. Flying to Kampala, wherever that is, with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane. So the speed of the wind, I guess we'll call W for wind. And the speed of the plane, oh, I don't know. Let's call that P, just randomly. So those are my 2 unknowns, 2 variables. Now here's how problems like number 3 can work. Did you know that when a plane is flying with like the wind at its back, you can just kind of like add the speed of the plane with the speed of the wind? Or at least that's what we do in these problems. So when the wind was when those 2 speeds were sort of combined, the plane and the wind together, those 2 speeds totaled a speed of 158. So check it out. W plus P equals 158. Wind speed, plane speed, total speed. It's really that simple. But going back into the wind, see now the speed of the wind is kind of working against the plane. So it's almost like you're subtracting the wind speed from the plane speed. So negative wind speed plus plane speed, 112. And this works out pretty good because check it out. Already opposites. The elimination method applies perfectly. Like the conditions can never be more perfect for the elimination method than this situation. Already opposites, baby. Cancel out. P plus P, 2P. Oh boy. What is it? My human calculator skills. 200, 270? 270. I'm Ron Burgundy. Let's go with it. I mean, you guys can't see this, but there's a calculator literally like 6 inches from my hand right now. All I got to do is move my hand 6 inches to the right. I'll prove it. Bam. But let's go with 270. So that means you divide both sides by 2, and you get the plane speed. Once again, calculator's right there, but let's say 135 kilometers per hour. And if that is the speed of the plane, that means wind plus 135 would total 158. Do a little subtraction and get 23 kilometers per hour. That's a lot of miles per hour. What video did I just reference there? Scott Sterling. That clocked in at an astonishing 95 kilometers per... Okay. So that was number 3. The other one I'm going to do for you is number 6. So number 6 is comparable to number 3, I guess. Something else you have to keep in mind with number 6, there's a little bit of an extra plot twist with number 6. You got to realize that distance equals rate times time. It's a pretty universal, common formula that we use in math and physics and all over the place. I mean, the distance traveled is equal to the rate that you're traveling multiplied with how long, time, you've been traveling. That's just a pretty basic formula that applies to the universe. So, once again, 6 is comparable to number 3 because you're in a boat and the speed of the current either helps you or it takes away from you. You know, like you have the speed of the boat in still water. I don't know if we're like rowing or there's a motor or something. I don't know, but the boat has a speed, and then the current, you're either like adding the speed of the current onto your boat speed or you're subtracting the speed, because you're going downstream one way and you're going upstream the other way. But also, you see how they're throwing in like time and distance? So it's not as basic as number 3. You know what I mean? There's a little bit more of a layer to it. So here's what we do. We have a distance of 210, right? Remember, distance equals rate times time. And we have a time. So going downstream, when the speed... And by the way, what's not known? The speed of the boat, the speed of the boat, and the speed of the current. Oh my gosh, come on. Paper folded up there. Come on. Anyway, so getting back on track. Oh my gosh. Work with me here. All right, sorry, little distraction there. So we have a time, 10 hours. So the time was 10, and the speed going downstream was these two speeds added together. So here we go, check it out. That is the rate going downstream. The time was 10. And those two items multiplied together would get us 210. Going back upstream, okay, it took 70 hours. So the rate when we were going against the current, that would have been B minus C. Multiplied by 70, because now the time was 70, and that was going to end up with the same distance. See, whether you're going downstream, it's the same distance. You know, we went 210 miles downstream and then 210 miles upstream, right? So you see, rate times time equals distance. Rate times time equals distance. Oh boy. So now we have to distribute 10b plus 10c equals 210. 70b minus 70c equals 210. Right? And once again, I think I'm liking the elimination method. I can make the c's opposites. How can I make the c's opposites? How can I make a 10c into a 70c? Wouldn't I just need to multiply by 7? So that would make it 70b plus 70c equals, oh boy, what's 7 times 210? Once again, my calculator is literally right here, but I don't care. I'm setting a bad example. So 7 times 210, 1,470. You should use a calculator. You know, I mean, I think I could have done that in my head, but once again, you should be certain. And the second equation, I didn't need to change. Now I can add these together. Those are going to cancel. That's what I planned. 70b plus 70b, that's 140b. And then 1,470 plus 210, that's going to be 1,680. And now you're going to have to divide both sides by 140. So 1,680 divided by 140, 12. So what was that? 12 what? $12? 12, 12 tigers? But no, 12 kilometers per hour? Miles. So 12 miles per hour. Okay? And if B was 12, that makes, let's see, so if what's the speed of the current? So let's use, gosh, what equation could we use here? Let's use this one right here. So 10 times 12 plus 10 times C equals 210. Now that I know that B is 12, so that's going to be 120. 10 times 12 is 120, and then when we subtract 210 minus 120, I think I know the answer, but 90. So 10C equals 90, which means C equals 9 when you divide both sides by 10. So the current was 9 miles per hour. Oh my gosh. 9 miles per hour, and the boat 12 miles per hour. So I did a lot of these for you. Number 5 you don't have to do. So you got to do number 2 and the problems on the back, which are like 7, 8, 9, 10, and 11. So good luck with that.